In this video, we're going to talk about the definition of an inverse function. So first, if we have a function from a set x to set y, we say that f is injective or one-to-one if for all x1 and x2 in x, x1 different from x2 implies that f of x1 is different from f of x2, that is, different inputs give different outputs, or as we saw, the contrapositive is equivalent, so that is that if f of x1 is equal to f of x2, then x1 is equal to x2. Now, we said that f is surjective or onto if for all points y in y, there exists an x in x such that y is equal to f of x. And now, if f is both injective and surjective, we say that f is a bijection or a one-to-one correspondence. I know that one-to-one correspondence sounds a bit weird, so let's just stick to the name bijection. But it's just in case you see it in some other books. Now, an inverse function. If I know that f from x to y is a bijection, then the inverse function f inverse from y to x is the unique function such that f inverse of f of x is equal to x for all x in x, and that f of f inverse of y is equal to y for all y in y. So the inverse, which as I said already, we denote it by like f to the kind of negative one, which, careful, is not 1 over f, is just the inverse function, is a function that reverses the effect of f. So that's what the inverse is if f does something, then the inverse comes and, well, undoes it. It's just what it is. So here we have an example. We have the function x cubed. So you see function x cubed takes -2 and sends it to -8, or takes 2 and sends it to 8. And then when the inverse that, which is the cube root, it takes 8 and sends it back to 2. So you see, that's what I said. If we first applied f and then the inverse, we applied f to 2. In this video, we're going to talk about the definition of inverse function. First, if we have a function f defined from a set x to a set y, we said that f is injective or one-to-one if for all x1 and x2 in x, if I know that x1 is different from x2, then f of x1 is different from f of x2. That means different inputs give different outputs. And if we look at the contrapositive of this statement, then another way of saying that a function is injective is that if I know that f of x1 is equal to f of x2, then x1 is equal to x2. And we say that f is surjective or onto if we know that for any point y in y, we can find a point x in x such that y is equal to f of x. Now, if I know that a function is both injective and surjective, we say that f is a bijection or a one-to-one correspondence. Let's stick to the name bijection, but I'm saying the other name just in case you see it in a book. Now, if I know that I have a function from x to y that is a bijection, then the inverse function is a function from y to x, and this is the unique function such that if I do f, what I'm going to call f inverse of f of x is equal to x for all x in x, and that f of f inverse of y is equal to y for all y in y. So what the inverse does is the function that reverses the effect of f. So if f does something, then the inverse is going to come and undo it. That's what it does. So let's take a look at this example with the function x cubed. You see, if I take the function x cubed, we can see that it takes -2, sends it to -8, but then the inverse takes -8 and sends it back to -2. So you see, if we apply f and then the inverse, this is what happens. We take number 2, we apply the function x cubed, we obtain 8. Then to 8 we apply the inverse and we go back to 2. But we can also apply first the inverse and then the function. So if I start with 8, then I take the cube root of it, I end up with 2. Then I take this 2 and apply my original function and take a cube of 2. 2 cubed is 8. So that's what it does. The inverse is the function that undoes what my original function f